Okay, class, let's do these questions. Question 1, e to the 2t multiplied by cos t. Now, these are the theorems. 1, 2, 3, 4. E to the at times something multiplying by t or dividing by t. These are the formulas for the theorems. Good. So, when we have a problem to work out, you first of all have to figure out which of the theorems it matches up with. Now, I have e to the 2t times cos t. Well, that would have to be the first theorem. So, we apply theorem 1. Now, the steps. Applying theorem 1. Step 1, identify what's f of t and what's e to the at to the minus at, and identify a and make a note of a. Then we're going to use the table to convert f of t to f of s, and then finally replace s with s plus a in f of s to produce f of s plus a. Good. So looking at this question, step 1, what is f of t? It says identify f of t and e to the minus at. Well, f of t would have to be cos t, and e to the minus at would have to be e to the 2t. Good. And then identify a. Well, if e to the minus at is e to the 2t, then negative a gotta be equal to 2. Negative a gotta be equal to 2. So a is just negative 2. Right? So we know our a is negative 2. That's the end of step 1. Step 2 says use the table to convert f of t to f of s. So we're taking our eyes off of e to the at and moving towards f of t now. We know f of t is cos t and a is negative 2. Yes, step 2, use the table. So if we convert cos t with the table, we will get s over s plus 1. That's it. And then finally, step 3 says replace s with s plus a to convert f of s into f of s plus a. Remember that a is negative 2. So f of s was s over s squared plus 1. So f of s plus a, where we see s, we just put s plus a. So I have to put s plus a was negative 2, s plus negative 2 over s plus negative 2 squared plus 1. Then, so this will be s minus 2 divided by s minus 2 all squared plus 1. And then we just expand the brackets and finish. As easy as that. Good. Next question. This one, we do this one next. Now, if we are going to do e to the 3t minus 1 all over t, look to see which theorem it resembles. Okay, that's clearly dividing by t. This dividing by t, which is this. So we apply theorem 3. Now the steps of that: first of all, identify f of t and t, and then use the table to convert f of t into f of s. Then we replace f of s with sigma in f of s to produce f of sigma. And then finally perform the integral as s goes, sigma equal s to infinity of f of sigma d sigma. And please note these notes. When these notes are for the integration. When integrating, always apply log rules when possible, and if you have to find a limit that normally produces an infinity of infinity condition, divide the top and bottom of the fraction by the highest power of sigma. Right, so we are going to work this question with theorem 3. So step 1, identify f of t and t. So f of t is equal to 1 minus cos t, and t will just equal to t. Yeah. So from the step 2 now says convert f of t to f of s. So we know just got to find the Laplace of this from the table. 1, the Laplace of 1 is 1 over s, and the Laplace of cos 2t is s over s squared plus 4. Look at the table and you could find that very easily. Now, step 3 says, replace, wherever you see s, put sigma, and that will be f of sigma. So step 3 says, if f of s is this, the f of sigma is, all we do is write back the same function f of s, but where we see s, we put sigma, and that's it. Step 4, solve the integral. Solve the integral f of, solve this integral s sigma equal s to infinity of f of sigma d sigma. So we just put our function right here. This is f of sigma right there, d sigma. Good. Now, the first thing I did, don't worry with this line as yet. The first thing I did is to split the integration to make it kind of simpler to see. So I just multiplied d sigma by this and d sigma by this, and I just, just split the integration, the integral. Good. Now, we know if we integrate 1 over x with respect to x is just ln x. So this part is easy. This part is not that straightforward. Now, whenever you have a fraction to integrate, always just look to see if we differentiate the bottom, that's beside the top, or when differentiate the bottom, you have what's at the top, multiply by some number, right? Oh, one other thing, when you differentiate the bottom, you must have what's at the top times d theta. Or when you differentiate the bottom, you have to the top times some other number, also times d theta or d sigma. Don't worry, I will stop mistaking sigma sometime. Good. Now look at this. If we differentiate this, the bottom of the fraction, we will get 2 sigma. What's at the top? At the top is sigma d sigma. Now, I said if you differentiate the bottom and you get what's at the top times d theta, or what's at the top times d theta times some other number, you can do u substitution. So, if you differentiate this, you get 2 sigma, but what's at the top is sigma d sigma. So, it does qualify for u substitution. And then, what you do, if you don't understand it, you can just YouTube u substitution examples and learn it back from someone else. Right, so always let u be the bottom of the fraction. So u is equal to sigma squared plus 4, and then differentiate it. So the u d sigma is equal to 2 sigma. So du is equal to 2 sigma d sigma. But what we have at the top is sigma d sigma. So we got to make sigma d sigma appear on this side. So du is equal to 2 sigma d sigma. So sigma d sigma is equal to du over 2. So I had sigma d sigma over sigma d sigma, which I called du over 2, and the bottom I had sigma squared plus 4, which I call u. So sigma d sigma divided by sigma squared plus 4 is actually du over 2 divided by 2. Right? Now this is a note to the side. Du over 2 divided by 2 is the same thing as du over 2 times 1 over u, which is the same thing as half times 1 over u times du. So I will rewrite this as this and factor out the half. So this is the integral we actually will perform. Now we can actually integrate without adjusting anything else. So when we integrate 1 over sigma with respect to sigma, it's just ln sigma. And when we integrate 1 over u with respect to u, it's just ln u. So this is just ln sigma, and this is just half, because half is outside ln u, and I put the upper and lower boundaries on both of them. Then I just make it one solution with one upper and lower boundaries. Remember, I only split it so you can see the u substitution easier on this side, but since that's already split, I put it back as 1. Now the first note, in the first note I said always apply log rules where possible. So you have log of something minus log of something else here and here. We know log a minus log b is equal to log of A divided by B. But it actually has to be log A minus log B. It can't be log A minus 2 log B. Or log A minus half log B. Remember, log is ln is a log, right? This is ln A or log A minus ln minus half ln something else. So I gotta get rid of this half in some way. I gotta get rid of this half. I can do one of two things. I could use this. All right, I have something in this form: minus n log b. I have log A minus some other number log b. I could do it like this: log b to the n, and then I have log of something minus log of something else, right? But if I do that with this question, I'll end up with ln of this to the half power. And I don't want to have sigma squared plus 4 all to the half power, because that's going to be binomial expansion with fractional powers, and we don't want to get that messy in Laplace, right? So I'm not gonna do that. I gotta find a next way to get rid of this half. And what I'm gonna do is try to factorize it out of this expression. Now, is there a half here and here? I don't see one, but I'm going to make one. So we know it's just a 1 in front here, but I can rewrite 1 as half multiplied by 2, or 2 times a half. So I will rewrite this entire line here and call it 2 times a half ln sigma minus half ln everything else. And then I could factor out a half. So when I factorize the half, it will just be 2 ln sigma minus ln sigma squared plus 4. Now I have a 2 here, but I could use this rule to put the 2 at the top, because if I do it, I will end up with ln sigma squared, and there is nothing wrong with the sigma squared. There was something wrong with the sigma squared plus 4 all to the half power, because that would have been binomial. Nothing wrong if you have a 2 at the top here. So I put this here, and then finally I apply the log rule, because I have ln of something minus ln of something else. So it's ln of the first thing divided by the second one. So I simplified the solution to be in this. Now I have to put in the upper limit and the lower limit. So it would be half multiplied by ln of this with the upper limit minus ln of this with the lower limit inside. Now look at this. When you put in the upper limit, infinity, what you would get? You get ln of infinity over infinity. And note 2 said, if you have something with infinity over infinity, you divide by the highest power of sigma. So I would not even substitute this in here, since that's going to give me infinity of infinity. I would adjust this expression by dividing top and bottom by sigma. So I'm going to write back everything, but here I'm going to divide this by sigma, this by sigma, and this by sigma. So this should be sigma squared divided by sigma squared. Divided by sigma squared, sorry. This is going to be sigma squared divided by sigma squared divided by sigma squared, and 4 divided by sigma squared. And of course, sigma squared divided by sigma squared is going to be equal to 1. So this would be our result. Good. Now, after dividing top and bottom by sigma squared, then you can put in the infinity and you wouldn't have a problem. Right? So let's put in the upper and lower limits. So it is half multiplied by ln of this with the upper limit minus ln of the same thing with the lower limit. So that's what I did here. Now 4 over infinity squared, or I should say the limit of 4 over infinity squared, is equal to 0. So I have 1 over 1 plus 0. 1 over 1 just 1, so I have half multiplied by ln1 minus, well, this is not a value, just put s. ln of 1 is 0, you can put it in your calculator. So I have negative half times 0, this is equal to, and I have negative half times, sorry, I have half times 0, and then half times negative ln of this. So 0 minus this is just, well, this. So you have minus half ln of 1 over 1 plus 4s squared. I have a fraction here within a fraction, which does not look good. So to neaten it, I multiply top and bottom by s squared, and I will get this. Now I put a star here because I would leave my answer as this, but to get it how the book has it, they just put up the negative half as a power, and they just flip this and call it to the half power and then put the square root sign. Remember, you can flip it and call it the half power because when something says negative half power, it's like it's at the bottom of a fraction. And if you have a fraction at the bottom of a fraction, you just upturn the fraction. Like 1 over 4/5 is just 5 over 4. Right? You should kind of know that. Alright, next question. We want to find the Laplace transform of t times cos 3t. So let's go. Which theorem does it resemble? Well, it's multiplying by t, so we use theorem 2. The rules are: step 1, identify f of t and t. Step 2, use the table to convert f of t into f of s. Step 3, differentiate f of s to produce f prime of s. Step 4, multiply f of s produced here in step 3 by -1 to produce negative f prime of s. And that will be our answer. Now step 5 says, if necessary, repeat steps 3 and 4 by, well, for step 3 and 4 for every power of t greater than 1. So if it's a second power, that's 1 greater than 1. So we repeat step 3 and 4 one at a time. If it was t to the second power or something. Anyway, we don't have that right now. We just have this. So step 1 says identify f of t and t. So f of t will be cos 3t, and well, t is just t again. Step 2 says use the table to convert f of t into f of s. So we have one of the Laplace of cos 3t, which is just s over s squared minus 9. That's just it. And step 3 says differentiate f of s to produce f prime of s. So f of s is this. We want to produce f prime of s. We just differentiate f of s with respect to s. Now when we differentiate this, we use quotient rule. Just look at what I did here. So differentiating, we just do this, apply quotient rule, and we get this. Step 4, just multiply by -1. The top, so just change the sign. So you have s squared minus 9 over s squared minus 9 r squared. And that is it. As simple as that. Now, next question. Suppose we were asked to find t squared times cos 3t. Alright, good. Next question, we want to find the Laplace of t squared cos 3t. Now, you can consider when you're doing multiplying by t to the n or just t in general. You also identify f of t and then find f of s. And you gotta differentiate f of s by whatever is the power of n on the t. So it's t squared. So we know when we first find f of s, we would have to differentiate it twice. Just bear that in mind. But we can still follow our steps. So step 1, identify f of t and t to the n. Well, f of t is equal to cos 3t again. And t to the n is t squared, so n is equal to 2. So we know we will differentiate twice. Now, use the table to step 2, use table to convert f of t into f of s. So now we know that, so cos 3t is equal to s over s squared minus 9. Step 3, find the derivative of f of s. So we differentiate this once again by quotient rule. We get this. This is the same derivative we did just now. So we should end up back to the same answer. To the same answer here. Right, step 4 was multiply this by -1, so we get this. Good. Now, because we don't just have t to the first power with something else, we go to step 5, which is just repeat step 3 and 4 one at a time. So we're gonna differentiate this by with respect to s, and then multiply it by -1. Then we finish. Right? We differentiate again. This is the general formula for it. Anyway, so we gotta repeat step 3 here and differentiate what we just had. So we're gonna differentiate this thing, our last answer with respect to x. And when I differentiate it, I wouldn't explain this whole long differentiation. You could just pause and look at what happened here. This is not explaining differentiation. This is not what this video is for, right? Alright, good. So we get this. Good. Now at this stage we multiply by -1, which is in step 4. Remember step 5 just said repeat step 3 and 4. So this is the end of the second step 3. And then our second step 4, multiply this by -1 and we get this. And we can factorize out a 2s to produce this. Right? And that is the solution for that. Now look at this question. What theorem is this? This question. Is it theorem 2? We are multiplying by t to the n, so it could be that. Or is it the force shift theorem, because we are actually multiplying by e to the -at. So which one do we do? We could actually do any one of them, and just as a diversion, you can actually look at this as being theorem 2 and apply all theorem 2 questions to theorem 2 steps to the working and get an answer. Or you can look at it as being the force shift theorem and apply the force shift theorem rules so you can get the same answer. So it does not matter which one you choose, but which one do you think it makes more sense to choose? If we consider it as being multiplying by t to the n, it means we'll find the Laplace of this, and then we will differentiate 3 times, which will be some amount of work, right? Now, the force shift theorem just says find the Laplace of this, and then just change s to s plus e. Obviously, the force shift will be shorter, right? So we apply force shift theorem. So those rules say, step 1, identify f of t and e to the -at. So f of t would be t cubed, and e to the -at would be e to the -4t. Right? So minus a is equal to -4. So a is just 4. If you had used multiplying by t, you would call this f of t and this t. Right? But since we are using force shift, we call this f of t and this e to the -at, depends on what you're using. Good. Step 2. Use table. So we know a is equal to 4. Use table to convert f of t to f of s. So f of t is t cubed. So from the table you can easily get this, and then finally replace f of s with s plus a, which we did here, and that is it. So this video covered all the theorems of Laplace transforms. If you have any questions, call me.